Vertical asymptotes, which I'm going to use VA for, is a vertical line which the graph approaches but never touches. Okay, so a horizontal asymptote, sometimes it crosses, but a vertical asymptote is never touched. So to find the vertical asymptote of a rational function, you simply set the denominator equal to 0 and solve for x. So this is kind of like what we did for the domain. We want to set the denominator equal to 0. So we're going to look at the denominator only. We are going to take that x plus 5 and set it equal to 0. And that gives us x equals negative 5. So our vertical asymptote is x equals negative 5. So for the next one, when we look at the denominator, we need to simplify this into factored form. So we're going to take x squared minus 3x plus 2, set it equal to 0. Factor out our polynomial, so we have two x's. There's a minus in the middle and a plus, so they're going to both be negatives, 2 and a 1. So we know that if we take x minus 2 equals 0, x equals 2, x minus 1 equals 0, x equals 1. So in this case, we have two vertical asymptotes, and they are at when x equals 2 and when x equals 1. So there are two times that the graph is not going to cross these lines. So for the last one, same thing. We need to take our x squared minus 5x, set it equal to 0. In this case, we need to factor out an x and simplify into factored form. So x times x minus 5 equals 0. Split it out. And we know on this side x equals 0, and on this side x minus 5 equals 0 gives us x equals 5. So our vertical asymptotes, and there are two of them again, are at x equals 0 and x equals 5. On this part, we're going to look for an oblique or a slant asymptote. So basically, a slant asymptote would be an asymptote that occurs at an angle. It's not horizontal, it's not vertical, it's at an angle. And this occurs when the polynomial in the numerator is higher degree than the polynomial in the denominator. So remember when we were looking at horizontal asymptotes, if the numerator was higher, there was no horizontal asymptote. Well, that's because we have an oblique asymptote. So to find the oblique asymptote, you must divide the numerator by the denominator using either long division or synthetic division. So I've got a couple of different examples on this. Okay, so for the first example, I look at this bottom and it's x plus 4. So I know that would be easy to do synthetic division on. So I would take negative 4 and then x squared is 1 minus x is negative 1 and negative 14. So you're going to do the synthetic division, which gives us 20 and 6. Okay, so the way you interpret this is we do not care about the remainder when we're trying to find an oblique asymptote. And we're going to use OA for oblique asymptote. So what happens is we take and we rewrite this equation. Well, we divide it into x squared, so we're left with x minus 5. So our oblique asymptote is going to occur when y is equal to x minus 5. So we're not worried about the remainder. We just drop that off and we just use what is left right here. All right, so if we look at this next example, the numerator has a degree of 2, the denominator a degree of 5. Do I need to divide this? What was the one rule that we said? We said that the numerator is a higher degree. So in this case, the numerator 2 degree is not higher than 5. So there is no oblique asymptote on here. And this is because the numerator degree is not higher than the denominator degree. And these are the last two examples. Find the oblique asymptote if any of the functions below. So on these examples, synthetic division wouldn't be quite as easy to use. So we're going to have to do our long division. So we're going to take 3x plus 2 divided into 6x squared plus 4x minus 11. So we would have to, what would we multiply times 3x to get 6x squared? That would be 2x. So that's going to go over the 4x. Okay, because 2 times 3 is 6, x times x is x squared, and 2x times 2 would be plus 4x. Now remember on this, we are subtracting this. So 6x squared minus 6x squared is 0. 4x squared minus 4x is 0. And we want to bring down the negative 11. So that means we have a remainder of negative 11. And remember, we stated previously that we don't care about the remainders. Okay, we do not care about the remainders. So the oblique asymptote would be at y equals 2x. And we don't need to keep the plus 0 because that doesn't change our equation in any way. So in the next example, we want to take x squared plus 2x minus 3 and divide it into x cubed plus 3x squared. Now we have to remember to add in the 0x plus the 0. So what we would do is x squared, what do I multiply times x squared to get x cubed? I multiply it times 1x. So that means I need to put it above the x column. X times x squared is x cubed. X times 2x is plus 2x squared. X times 3, negative 3 would be negative 3x. And then I need to remember to subtract everything on the inside. So x cubed minus x cubed is 0. 3x squared minus 2x squared leaves me with x squared. 0x minus a negative 3x gives me a positive 3x. Bring down my plus 0. So to get x squared, all I have to do is multiply times 1. So 1 times x squared is x squared, plus 2x minus 3. Subtract everything, so that's 0. 3x minus 2x is just x. 0 minus a negative 3 is plus 3. And that would be our remainder. And like we said previously, we don't care about the remainder in this situation. So that means our oblique asymptote is going to be located at y equals x plus 1.